This is May 2014, paper 1, time zone 1, so this is without a calculator. And this is definitely a question worth going over a couple of times because the use of the compound angle in this question, which we'll see in a minute, has been used quite regularly on IB questions over the past few years. So I've got the equation of a curve here. I've got to find dy by dx in terms of x and y. So first of all, what I want to do is try and work this out so that it's y squared into x in terms of y in terms of x squared. So very simply, I'm going to do arctan y squared equals pi over 4 minus arctan x squared. Now at this point I want to get rid of the arctan. The opposite of arctan is to take a tan of both sides. So when I do tan arctan, I'm just left with y squared. But now I've got to do a tan of the other side. Now it's not a tan of each individual thing. So it's not tan pi over 4 and tan arctan x squared. It's tan pi over 4 minus arctan x squared in a bracket. Now then, at this point, you're going to have to look at your compound angle formulas. Now, on the compound angle formulas, you've got this compound angle here. So what we've got is tan. This is your A, and this is your B. So I'm going to use the minus, because we've got a minus in here, and I'm just going to rewrite that using this compound angle formula. So it becomes y squared equals tan pi over 4 minus, now when I do tan arctan, it just becomes x squared. So this is how we're getting rid of the arctan over here. And then we've got to divide it by this 1 plus tan A tan B. So we're going to have 1 plus tan pi over 4 x squared, because tan arctan x squared. So now I'm going to work out what tan pi over 4 is. That's just 1. So this is going to be 1 minus x squared on the top. And on the bottom, we're going to have 1 plus x squared. This is 1 plus, and this is 1 times 1x. So I've got y squared equals this. Now I want to actually differentiate it. So the y squared, that's fine. I can differentiate that. This is 1 minus and the other one's 1 plus. I can differentiate y squared. That's not a problem for me. This now becomes the use of the quotient rule. Now you can see there's a lot of work for 4 marks. But we're going to use some of this working out in the next question, particularly this. So just to show you how I use the quotient rule here, my u is number on top, and then I differentiate u to give me minus 2x. My v is the number on the bottom. I differentiate v to give me 2x. Now I'm going to start putting all this back together. But first of all, let's differentiate this. This becomes 2y dy by dx. This becomes this one times this one, minus this one times this one, and we're going to end up with having minus 2x, 1 plus x squared, minus this one times this one, so it's also going to have a minus 2x, 1 minus x squared, and then on the bottom we're going to have 1 plus x squared squared. Now I'm going to tidy this up very slightly. Minus 2 times this and minus 2 times minus this is going to cancel out, and you can just check through my algebra here. But basically on the top I'm going to end up with minus 2x, and minus 2x give me minus 4x. I'm going to divide by 2y, and this is a long bit of algebra but fairly straightforward. And then this ends up being cancelling out the 2's. It's going to give me this. So I've actually done the differentiation. And now I'm going to go to part 2. Now that seems like a lot of work for 4 marks, and it is. And this part is worth 5 marks, but it's not as much work because you've done most of the work using that method. So now I've got to find the gradient where x equals 1 over root 2. So the first thing I'm going to do is I need to find out what y is when x equals 1 over root 2. So normally I think about putting it into this equation, but that's actually too difficult. So what I'm going to do is I'm going to use this equation here to find out what y is. So this is part B. This is 1 over root 2. You can check that question paper again. So y squared equals 1 minus 1 over root 2 squared, which is a half. And divide the whole lot by 1 plus a half. Now this is going to give me a half divided by 3 over 2, which is 1 over 3. And this is y squared equals 1 over 3. So y equals plus or minus the square root of a third. Y is less than 0, so y is minus 1 over root 3. So an x equals 1 over root 2. So now I'm going to put these values into here to get the gradient. So this is going to be, and you can double check as I put these numbers in, so this is what I'm putting it into. You might want to copy that down because I'm going to use another page. Dy by dx, the gradient that I'm looking for is minus 2, 1 over root 2 for x. And on the bottom, it gives me minus a third, that's y, and 1 plus a half, 1 plus a half squared. Now that's, sorry, 1 over root 2, and that's the 1 over root 2 squared, the x squared, and then I'll square it again. Let's make that nice and clear. So that's going to be, just so that we're not confusing you, I'm trying to do a couple of steps there. 1 over 2, so that's going to give me 3 over 2. So on the top I'm going to have minus 2 over root 2, and on the bottom I'm going to have 1 over root 3 times by, this is 9 over 4. And I've missed a minus out there because the y is minus. The two minuses cancel. We can put the root 2 with the 9 on the bottom of my equation. And again, this is just algebra. These two can come to the top, so it becomes 8 root 3, and on the bottom 9 root 2. Sorry, that's a 9 root 2. And we can even cancel out, we'll get rid of the root 2 by multiplying the top and the bottom by root 2, giving me 8 root 6's divided by 18, and that gives me 4 over 9 root 6. So in actual fact, this, apart from doing the number work here for part B, because of the method we use for part A, it made part B a lot easier. And this idea of using the compound angle here with tan has been used a lot over the last few years at a higher level.